Okay. So you have done the activity. So now what you should have found out from the activity is these two postulates here, which we originally went over as well with the pictures, and we talked about side, side, side being that SSS that you have. And what it's saying is that if three sides of one triangle are congruent to three sides of another triangle, then the triangles are going to be congruent. And through the activity, you should have been able to see that as many triangles as you made, they all were going to be congruent if you're using the same side length. So if you have a side length of 3, a side length of 4, and a side length of 5, if you put them together, no matter how you try to sort them together, they're always going to be congruent. And the second one that you investigated was that side angle side, or that SAS postulate, and that says that if two sides in the included angle, so that included angle is in between the sides, so of one of the triangle are congruent to two sides in the included angle of another triangle, then those triangles are going to be congruent as well. Okay, so what we're going to look at is, can we tell if the triangles are congruent by these two postulates? So in example 1, is triangle ABC congruent to triangle XYZ, and how can you tell? Okay, it's important to notice how these are written. So what they're asking is, can we say triangle ABC is congruent to triangle XYZ? Okay, is that something that we can say? Sorry, I have to switch the thickness, it keeps changing on me. Can we say that triangle ABC is congruent to triangle XYZ? And what we know is that we need to match A with X and B with Y and then C with Z. Those angles should all match up, as well as look at what postulate are we talking about. Now, these two triangles that you have here, you have 2 tick marks, and then an angle, and then 1 tick mark. And this triangle, same thing, you have 2 tick marks, an angle, and then 1 tick mark. C and Z, these are your included angles. And I'm going to say that since we have this angle here, that this is going to be congruent by SAS. That's your answer here. And then how can we tell is we're looking at these triangles and we're seeing that they have 2 sides congruent with an angle and then 2 other sides congruent with an angle. Now you should also start to be able to see, can you kind of flip ABC, flip or rotate ABC so that it would fit on top of XYZ. Okay, that's what we want to be able to start to see. I could see that ABC could be kind of flipped over and then pushed or rotated and moved over, translated to be on top of X, Y, and Z. So I see that C and Z definitely match. We were given those. And you can also start to see that angle B is the one with the 1 tick mark next to it. So angle B is congruent to angle Y. And therefore, you also have angle A congruent to angle X. They both are next to, these two are next to the ones with the 2 tick marks. You see A and X here. Okay, so checking to make sure, and this one's going to be, yes, congruent by side angle side. If we look at the second example at the bottom of your page, it says, you can show that 2 triangles congruent by using SSS or SAS, so side, 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 or side angle side. Show that triangle JKL is congruent to triangle FGH for Y equals 7. So again, we're trying to flip these on top of each other. You also need to see what ones are going to be, and sorry about this, 27, we don't need this here. So triangle JKL congruent to triangle FGH for y equals 7. Okay, I see y is here on the side lengths. Okay, and I see that I have two side lengths here, so those are going to match up, as well as I see that I have 40 degrees, and then here I have this as well. I have 5y plus 5 degrees. Okay, according to this, we should have angle J congruent to angle F, angle K congruent to angle G, and angle L congruent to angle H. So since I know this, what I can do here is I have J, okay, this is also talking about F. F is also talking about J, so these two should be the same, and I can start to match them up. L is also talking about H. H is also talking about L, and K is talking about G, and G is also talking about K. So now that I see this and I match these up, I can see now that K and G are the same, and this is one of the angles. These two are the same here, so what I can do is say 40 degrees, is this going to be equal to 5y plus 5? And I want to plug in 7, because that's what was given to me. So is 40 degrees, is this equal to 5 times 7? I plugged in y, I plugged in for y, 5 times 7 plus 5. Well, this is going to give me 35 plus 5, and I'd say yes. So that works. Okay. I also see that this length right here, I'm just going to do one more, this length that I have here, 4y minus 1, this is really FG, but I know that FG is also JK. So if I look up here, I see that I have JK, and that value here is 27. So what I'm going to do is I'm going to say that FG equals JK, and I have 27 equal to 4y minus 7. Again, I want to plug in 7. 27 equals 4 times 7 minus 1. So I use the letters that I had, and now I'm plugging in. I know FG is going to equal JK. So I have 27 equals 4y minus 1. I plug in 7, and then I have 27. Is this going to equal 27? 4 times 7 is 28 minus 1. So 27 equals 27. And we're all set. Sorry about the bell. This is all going to be correct. You could do the same for 13 and y plus 6. I'm not going to do it right now, but this is going to be congruent. And how I know this again, I have a side, an angle, and a side. So I have these two congruent. I have an angle here that's congruent to this angle here, and then I have a side length, and those would be congruent as well. So again, we're using side angle side would be what we see here. Okay, complete the work on the back here. See if you can determine whether we're using side angle side or side 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 or neither.